So, hello. This is a talk on water vapor, comparing monthly zonal mean water vapor records. There are 3 data records on the market, and this study was done as part of ESA's climate change initiative. There is a water vapor project, so I presented ozone yesterday. This is a similar project, but on water vapor, where a number of water vapor products are produced. And one of the 4 that are being produced will be presented here. And I'd like to talk to Patrick and say, if you're interested in total column water vapor, there's an interesting data set there as well. So this is all merged, etc., long term. So in this study, I looked at this recently published water vapor record by CCI. There's the swoosh data set, and there's the ghost cards data set. So these are the 3 long-term, vertically resolved, monthly zonal mean data sets on the market. And they differ, they have some differences. They differ in the actual reported sampling resolution, the time coverage, the sensors used, the data versions used, the auxiliary data used to do the conversions of profiles in different retrieval units. There's different correction methods. You have different references used to do the correction, and then different ways of actually calculating the uncertainty of the final water vapor values. So, okay.
Daan, sorry, what are the black dots?
Oh, okay, this is just, the black dots are data, and the red you shouldn't look at. This is the regression, because this whole talk will be about regression. So I will show more time series. So this is an example of the water vapor data set by CCI and which limb occultation sensors go into these. So there's actually most of the sensors measuring water vapor since the early mid-80s have been included. Then there is swoosh, heavily based on SAGE and MLS, and additional sensors like HALO and the SAGE instruments on Meteor and ISS. And swoosh also based on MLS heavily, and HALO, but not SAGE. So this means for this particular data set, cannot go into the 80s, and there's some good reasons for this. So you have to keep these differences in mind. So the methodology, so the purpose here is to use these data sets, look at variability and long-term changes. So how do we do this? We run a regression on these time series. We regress the annual cycle, so both 6 and 12-month components. We have a term for QBO, and then we have a term for long-term changes. And this was modeled as a piecewise continuous term with 3 periods. So I will mention results for these different periods later on. And then there are the residuals. And if you look at the residuals on the right-hand side, for instance, you see pressure and latitude for one particular data set. You see that the explained variance is quite high, down low, and at high latitudes. And this coincides with the regions where the seasonal cycle is very dominant. And it's very easy to explain the variance from the time series, but elsewhere it's actually quite hard. And you only get variances of the order of 25, explained variances of 25 to 40%. So most of the variability cannot be accounted for by the regression model. Okay, so I mentioned the baseline regression model. I tried other terms as well. So this is showing explained variance for the baseline regression model for ghost cards. And when I add in a solar term, I get almost the same result. If you would look at the differences high up in the lower mesosphere, you do note some impact of solar solar influence on the water vapor time series. At the bottom you see the residuals of after taking out all of the terms except for the solar term, you get the black dots, and then the red curve is the fitted solar term on this time series. So there seems to be some influence by the sun in water vapor high up, but elsewhere it's actually not very convincing. Other tests using ENSO or volcanic aerosol didn't really help to explain a lot of the variability, so they are not really considered. So in the next few slides I will go over each of the terms for the 3 different data sets. So here you have always pressure on y-axis and latitude on x-axis, CCI dataset, the ghost cards dataset, and the swoosh dataset. And this slide is on the long-term mean, so this is the constant in the regression model. And it's showing very good agreement between these 3 datasets. Now at the bottom plot you see the difference of ghost cards and swoosh relative to CCI. And they show clearly that the agreement is within a few percent, and that the spatial structure is very similar. Overall, CCI dataset tends to be a little drier than the other 2 datasets. So this is not the constant, but the amplitude of the 12-month cycle. As I've shown before, you have a huge amplitude in the upper troposphere, in the polar regions, and also in this region. And this is exactly coinciding with where the explained variance is high. So again, 3 data sets, they have a very good agreement in the magnitude of the amplitude and the structure. This is the phase of the 12-month cycle. So this is a bit of an eclectic plot, but it's very convincing. So it looks like the cycle in these 3 different datasets, the annual cycle is in very good agreement. Another quasi-periodic signal is the QBO, showing amplitude here, also here, same magnitudes and structure. At the bottom you see that the colors are a bit more pronounced, so seemingly showing higher differences between these datasets. But this is a very small signal anyway. We are talking about less than 0.05 ppmv in the amplitude of differences. So again, quite convincing results. So in the end, we are quantifying these periodic signals, not just out of interest for these signals, but also to have a better shot at inferring long-term changes. So this is a post-stamp plot where you have all the time series, the residual time series after taking out all the periodic signals. So basically you see what is left over in the long term. And then left to right is latitude, so left is South Pole, right is North Pole, and then up, down, you can guess is going from lower mesosphere down to the upper troposphere. And what I wanted to point out here is just, it's a nice plot, but also the CCI data set comes with flags, quality flags. So this is the suggested quality flag. This is the most restrictive data set. But if you're interested in having more data sets, if you can live with possibly the additional uncertainty, you can relax a bit this quality flag. So then you get a bit more data at the top, and the last quality flag gives a bit more data in the early part of the mission when the stage 2 instrument is measured. So, trends. I mentioned trends are modeled in 3 periods. They are piecewise connected, so this means a too low trend in one period will go into a too high trend in another period if you're not doing your job well. So this is the first period, leading of using measurements up to the start of '98. I mentioned ghost cards. Ghost cards has some data in this early period, but it's just a few years, so it's not enough to be comparable to CCI and swoosh data that start already in the '80s. So that's why it's grayed out. So when then you look at trends, it's a function of pressure and latitude for CCI and swoosh. You see blue colors, so I picked this scheme because blue is kind of wet, and then so these are positive trends. So you have wetter trends over most of the stratosphere, and then drier trends in the lowermost stratosphere and upper troposphere. So the structure again, so all of these trends are significant, so they are very clearly present in the data set. And the structure between these two data sets agrees, and if you look at the differences at a quantitative level, CCI and swoosh trends agree within 0.1 ppmv per decade, so that's quite convincing. However, you have to be a bit more careful. If you are interested in trends in the polar regions, you notice these very high dry or negative trends in water vapor for both data sets, while this is not the case in neighboring latitudes. So this is most likely a sampling issue, because at these high latitudes you can lose coverage, so the trends change, or there can be other issues because you just have not enough, you don't have enough data. So polar regions, be careful. CCI data is having a discontinuity at this level. This is also related to the fact that at higher levels the SAGE data are not part of this data set in the early periods, so you have a discontinuity because of a change in the sensors. If you apply the most strict criteria of quality flag for CCI, this discontinuity almost disappears. And I think this is probably the reason why Sean didn't include the early time period here. So that's why swoosh is stopping currently at, was it 1 hectopascal or around 1 hectopascal? So trends in the middle period, 1998 to 2003. This is a period with very clear negative trends, so drying tendency across the entire stratosphere for all three data sets. A bit striking is the swoosh data set in the upper stratosphere shows wetter trends, while this is not seen in Ghost Guards and CCI. I don't really have a good reason for a good understanding of this. When I looked at the previous swoosh version 2.6, this was also present there, so it's definitely not related to the change in versions of data sets used, etc. So here, although the sign is similar, if you look at it at a quantitative level, there is much higher discrepancy between the magnitude of the trends up to 0.4 ppmv per decade. Again, be careful about high latitudes and this discontinuity in CCI at this level. So then the last period, and these are the trends that are then comparable in period to what Patrick showed earlier, but for a merged time series. In this period, all data sets show wettening atmosphere across most of the stratosphere, lowermost mesosphere. In this region, the northern middle stratosphere, these two data sets show negative trends, so drier trends, while for CCI there's positive trends, but significance is very low, so the differences are on the edge of being significant between these data sets, but overall the values in the trends are quite small. Elsewhere, trends are quite clearly positive, about 0.2 ppmv per decade, or a bit more depending on the location. But overall, good agreement between these three data sets for the recent time period. So this is then the end of the talk. I would say that with the addition of the CCI data set, which includes additional sensors, we have another record that is a bit more independent perhaps from the swoosh and Ghost Guards records. So this will help to find out about uncertainties by comparing trends from these records. So it's a valuable addition. When you look at the cyclic signals, they are in very good agreement. So I would say that these are now all very mature records and ready to be used for long-term assessments. Thank you.